The National Electrical Code, often referred to as NEC, mandates that the ampacity of service entrance conductors must be at least equal to the rating of the main breaker. In the given scenario, the main breaker is rated at 200 amps, but the service entrance conductors are number 2 copper. According to NEC Table 310.16, number 2 copper conductors with a temperature rating of 75 degrees Celsius typically have an ampacity of 195 amps when used in residential applications. Since the conductor ampacity of 195 amps is less than the 200 amp rating of the main breaker, this installation violates the NEC requirement. This situation introduces a potential safety hazard. The purpose of the service entrance conductors is to supply electrical power to the entire building. If the conductors are undersized, they may overheat when the building's electrical load approaches or exceeds the conductor's ampacity rating. Overheating can damage the conductor insulation, leading to short circuits, ground faults, and potentially fires. The NEC specifies minimum conductor sizes to ensure that conductors can safely carry the expected load without overheating. Secondly, service entrance conductors must be protected from physical damage. The installation of service entrance conductors in a drywall cavity without any conduit or other form of protection is unacceptable. Service entrance conductors are typically run from the service drop or service lateral to the main service disconnect. These conductors are often exposed to potential physical damage from various sources, including construction activities, renovations, and accidental punctures from nails or screws. Installing the conductors in a drywall cavity without protection leaves them vulnerable to such damage. If a conductor is punctured or damaged, it can create a short circuit, ground fault, or other electrical hazard. Conduit, such as rigid metal conduit, intermediate metal conduit, or electrical metallic tubing, provides a physical barrier that protects the conductors from damage. Alternatively, armored cable or other approved wiring methods can be used to provide mechanical protection. The electrician's calculation indicating a load of 125 amps does not justify the use of undersized service entrance conductors. The calculated load represents the estimated amount of power that the building is expected to draw under normal conditions. However, the service entrance conductors must be sized to handle the maximum potential load that the building could draw, not just the calculated load. The maximum potential load includes factors such as future expansion, simultaneous operation of multiple appliances, and unexpected increases in power consumption. The main breaker is intended to protect the service entrance conductors from overcurrents. If the service entrance conductors are undersized, they may overheat and fail before the main breaker trips. Therefore, the service entrance conductors must be sized to match or exceed the rating of the main breaker, regardless of the calculated load. To rectify the situation and comply with the NEC requirements, several actions must be taken. Firstly, the number 2 copper service entrance conductors must be replaced with conductors that have an ampacity equal to or greater than the 200 amp rating of the main breaker. According to NEC Table 310.16, number 1 copper conductors with a temperature rating of 75 degrees Celsius have an ampacity of 235 amps, which would meet the requirement. It is important to select conductors with an appropriate insulation type and temperature rating for the specific application. The NEC specifies different insulation types based on the operating environment and installation conditions. Secondly, the service entrance conductors must be installed in a protected location. This typically involves installing the conductors in a conduit, such as rigid metal conduit, intermediate metal conduit, or electrical metallic tubing. The conduit should be properly sized to accommodate the conductors and should be securely fastened to the building structure. Alternatively, armored cable or other approved wiring methods can be used to provide mechanical protection. The specific wiring method should be selected based on the local building codes and the specific installation conditions. Thirdly, the entire electrical installation should be inspected by a qualified electrician to ensure compliance with all applicable codes and regulations. A qualified electrician has the knowledge and experience to identify potential hazards and ensure that the installation is safe and reliable. The inspection should include a thorough examination of the service entrance conductors, the main breaker, the grounding system, and all other electrical components. Any deficiencies or violations should be corrected immediately. In summary, the electrician's installation does not meet the requirements of the National Electrical Code and poses a safety hazard. The service entrance conductors are undersized and they are not properly protected from physical damage. The electrician's calculated load does not justify the use of undersized conductors. To rectify the situation, the service entrance conductors must be replaced with appropriately sized conductors. They must be installed in a protected location, and the entire installation must be inspected by a qualified electrician. These steps will ensure that the electrical system is safe, reliable, and compliant with all applicable codes and regulations. The National Electrical Code provides detailed requirements for electrical installations to ensure safety and prevent electrical hazards. It is important for all electrical work to be performed by qualified electricians who are familiar with the NEC and local codes. Homeowners and building owners should also be aware of the basic electrical safety principles and should regularly inspect their electrical systems for any signs of damage or wear. By following these guidelines, it is possible to minimize the risk of electrical accidents and ensure the safety of people and property. Remember that electrical work can be dangerous, and it should only be performed by qualified individuals. If you are not comfortable working with electricity, always hire a qualified electrician to do the job. Electrical safety is paramount, and it should never be taken lightly. Improper electrical installations can lead to fires, shocks, and other serious hazards. Always follow the NEC and local codes to ensure that your electrical system is safe and reliable. When selecting conductors for electrical installations, it is important to consider several factors, including the ampacity of the conductor, the insulation type, the temperature rating, and the installation conditions. The ampacity of the conductor must be sufficient to carry the expected load without overheating. The insulation type must be appropriate for the operating environment and installation conditions. The temperature rating must be high enough to withstand the maximum operating temperature. The installation conditions can affect the ampacity of the conductor, so it is important to consult the NEC tables to determine the appropriate conductor size. In addition to the service entrance conductors, other electrical components must also be properly sized and installed. The main breaker must be sized to protect the service entrance conductors from overcurrents. The grounding system must be properly installed to provide a safe path for fault current. All electrical connections must be tight and secure to prevent overheating and arcing. By paying attention to these details, it is possible to create an electrical system that is safe, reliable, and compliant with all applicable codes and regulations. The electrical codes and regulations are constantly evolving to reflect new technologies and safety concerns. It is important to stay up to date on the latest codes and regulations to ensure that your electrical system is safe and compliant. The NEC is updated every 3 years, and local codes may be updated more frequently. You can consult with a qualified electrician or your local building department to learn more about the latest codes and regulations in your area. Electrical inspections are an important part of ensuring electrical safety. Electrical inspections are typically required for new construction, renovations, and repairs. The purpose of an electrical inspection is to verify that the electrical installation complies with all applicable codes and regulations. Electrical inspectors are trained to identify potential hazards and ensure that the installation is safe and reliable. If you are planning any electrical work, it is important to obtain the necessary permits and schedule an electrical inspection. This will help to ensure that your electrical system is safe and compliant. In conclusion, electrical safety is a critical concern that should never be taken lightly. By following the NEC and local codes, hiring qualified electricians, and obtaining electrical inspections, it is possible to create an electrical system that is safe, reliable, and compliant with all applicable regulations. Always remember that electrical work can be dangerous, and it should only be performed by qualified individuals. If you are not comfortable working with electricity, always hire a qualified electrician to do the job. Electrical safety is paramount, and it should always be your top priority. Number 1 copper conductors with 75 degrees Celsius insulation are typically rated for 235 amps, which is more than the 200 amp breaker requires. Conduit protects from physical damage, which drywall alone does not provide. The conductor size needs to handle the maximum potential load, not just the calculated load. Have a qualified electrician inspect the whole installation for code compliance.